Hi, Sheik. How are you?
I'm fine, Maria. Except for the recent hit on my right elbow, which hurts.
Oh, what happened?
The elevator door slammed on my right hand when I got in.
Oh, the elevator door sensor failed dangerously.
What do you mean by failed dangerously?
It means it failed to carry out its safety function of stopping closure and retracting the door when it sees a movement.
Oh, that's interesting. Then there should be something called failed safely?
Yes, Sheik, you are right. If the door sensor wrongly senses someone when no one is there between the doors and opens the closing door, or prevents closing of the open door, then it's safe failure.
Oh, that means the elevator door will not close and the car will not move.
Absolutely.
But safe failure only causes stoppage of elevator, but dangerous failure results in harming personnel.
True.
But how can we reduce getting hit by these doors slamming due to dangerous failure of the door sensor?
The sensor reliability and/or availability can be increased.
I understand reliability, which means making the device more robust, which in turn increases the failure duration of the sensor. But how to improve availability?
By increasing redundancy and making it fault tolerant.
That is above my head. What is meant by redundancy?
It's simple. Add one more sensor and configure such that, if any one sensor senses a dangerous condition, it stops door closure. Now, out of the two sensors, if one fails dangerously, it does not matter, as there is a redundant sensor to make the function succeed.
Oh, now I understand. It's similar to brake lights in my automobile.
Which means
a set of brake lights are along with the tail lights, and one more brake light is inside the rear windshield. If one of them fails, the other will still indicate braking. They are redundant to each other, right?
yes, something like that.
Okay, but if I'm doing the design for these functions, which, when fails, can result in a hazard, how will I know what should be the minimum acceptable failure rate, required level of redundancy, etc.?
These fall under a branch of study called functional safety.
One more new term. Functional safety. What's that?
Functional safety is the part of the overall safety that makes the system or equipment operate correctly in response to its inputs.
So functional safety is applicable to industries like automobiles and manufacturing?
They are also applicable to various other industries like process, aviation, nuclear, medical devices, ship dynamic positioning, railways, etc.
Oh, that's a whole lot. I have little knowledge of process industry. Can you explain how it applies to the process industry?
In process industry, apart from using instrumentation for control, instrumentation is used for protection and mitigation. Let's consider a tank storing petroleum products. In case the tank overfills, the highly flammable product overflows, and if it finds an ignition source, can result in high-intensity fire causing destruction. You might have heard about tank fires.
Yes, heard about Buncefield fire accident in the UK and a few more.
Right. So in order to stop the tank from overflowing, there will be a high-level detection instrument, which when detects, takes action to stop level from raising further and overflowing. So this high-level protection function is a functional safety function.
Oh, okay. There should be many similar functions in a process facility which protect us against major hazards.
Yes.
But these protections are dormant in nature. That is, they need to work only when demanded. In your example, high-level protection function is not always working, as there is no high level in normal operation of the tank. Only if there is an abnormality, the function is demanded to work and prevent overflow of the hazardous liquid.
Absolutely.
Further, how to determine the required availability of the function, how to find these devices meet the required availability, how to make sure everything that goes into performing the function is correctly specified, engineered, procured, and installed, how to get the confidence that the devices will work when demanded.
Okay, there are standards which answer all your questions.
Oh, okay. What are those standards?
There is an umbrella safety standard called IEC 61508 and sector-specific standards, like one for process, one for machinery, one for nuclear, etc.
Which is the standard for process industries?
It's called IEC 61511.
So if I'm in process industry, I need to follow IEC 61508 and IEC 61511.
Yes.
They prescribe ways to meet the functional safety requirements.
No.
Then,
Both the standards are performance-based and not prescriptive.
Again, it's over my head.
In our tank level example, if the standard says install 2 level sensors and vote 1 out of the 2, then it's prescriptive. But if it simply says design the sensors such that their probability to fail dangerously on demand is less than 1%, then it's performance-based.
It's easy to comply to prescriptive standards than performance-based ones. The performance-based standards need tools and methods to make sure the defined metrics are met.
Right.
Further, the personnel who perform these tasks of compliance should have the competence and skill.
Absolutely. In this portal, R&R consultants endeavor to provide high-quality tools and methods, as well as modular training courses to help meet the process industry function safety requirements for consultants and companies. The users are advised to feel free to explore and subscribe.
Oh, thanks Maria for all the details, and I wish R&R consultants good luck and Godspeed.